Hi Math 34 students. This is Module 3, Example 3 on page 79. So this example compares the speed to the gas mileage that a car is getting. And it tells us the gas mileage of an automobile first increases and then decreases as the speed increases. So we want to go ahead and make a scatter plot of mileage versus speed, find the linear regression equation and the R value. So we'll go over to Excel, and this is under Example 3 tab at the bottom if you download the Module 3 data file from Desire to Learn. So I'm going to highlight speed and mileage, go to Chart, choose Scatter Plot. We're going to choose the first scatter plot, and then in the chart layout choices, remember and f of x for function. Over to the right. Let me drag our chart up a little bit higher. What's nice about Excel is you can move your charts around, and we can also make our fonts a little bit bigger and darker. So I'm going to go to Home and make my font nice and big so you guys can see it, and bold. And we can see the chart is always labeled with whatever the y-axis is labeled. So the name or the title of the chart is mileage, because that's what we call our y-axis. You can click in here and change the axis titles. So we can retype this to say speed, and our y-axis title to say mileage. So if you're printing out a chart for me, you do want to make sure you do this. Okay, so if we look at our scatter plot, this looks more like a parabola than a line, right? As the speed increases, the mileage goes up and peaks right around a speed of 40 miles per hour, but then it comes back down when we go up to 60 miles an hour. So the faster your car goes up, then your mileage starts to decrease. Our equation is y equals 26.8. So there is no x in this equation because the linear regression equation is just this flat line going as best as it can through the middle of the data. And our r squared value is 0, so that means our r value is also 0. So our regression equation is y equals 26.8, and the correlation is r equals 0. And remember, you can use capital R or lowercase r, either way. I'll know which r that you're talking about, that's correlation. So now our correlation here is 0. So when correlation gives you a 0 score, that means there is no correlation. So we say there's no correlation between speed and mileage because the correlation value is 0. And this makes sense because the scatter plot showed a parabola shape and not a linear relationship. We could, if we thought this was really parabolic data, we could go ahead and do a quadratic regression, and we could probably get an equation that's a pretty good fit. So in a case where the data isn't linear like this, you're going to get a correlation 0, and that tells us there's no relationship. Now let's look at example 4 on page 80. This example is about coffee and deforestation. So it tells us when coffee prices are high, farmers often clear forests to plant more coffee trees. That makes sense if they want to sell more coffee. Here is 5 years of data on prices paid to coffee growers in Indonesia and the percent of forest area lost in a nation park in a region where coffee is produced. So I think in Indonesia they're not as strict with the national parks, so maybe coffee growers are clearing trees there to make a profit, which is probably not so good. So we want to think about which is the explanatory variable. Well, in this case, we think that the high prices are causing farmers to clear forest, so that leads us to believe that price is the explanatory variable because it is causing the change. Okay, so then that would mean that the forest loss would be the response variable, although I didn't ask that question here. So now we want to make a scatter plot and look at what kind of pattern does the scatter plot show. So again, I'm going to go over to Excel. And then I'm going to go to Example 4 tab down here on the bottom. Highlight both data and go ahead and make a scatter plot. And it looks roughly linear if we look at our scatter plot. Not a perfect line, but the trend seems to be positive linear slope. Okay, so we can say the trend in the scatter plot seems to be a positive linear slope. Now let's go ahead and find the regression equation and the R value. So we can go back to Excel. And remember, in your chart layouts, choose the one with the line and the f of x. There's another choice that just has the line. If you choose that one, you're not going to see the function. So make sure you choose the one that says f of x for the function. And then I'm going to drag it over to the side and make the font bigger so that we can read our regression equation here. Let's pull it over a little bit. Okay, so we have here y equals 0.0543x minus 0.9764, and our r squared value is 0.91233. So remember, you can take the square root of the r squared to find the correlation, or if you want to go ahead and use an equation, we know we can say this equals and use the choral function. And then in parentheses, see where it's telling us to put array 1 and then array 2. Array 1 is going to be A2 to A6, so you can actually click and do it. Oh, see how it puts a plus in there? To change that, we would need to drag it down, I think. Oh, and see, it's still doing that. So maybe just type in the colon is faster. And then our forest loss is going to be B2 to B6. And see how, as we type it in, Excel highlights what they call that array. And we see the correlation, our R value here is going to be 0.955 and then a 2 if we round it. So you could take the square root of the R squared value or go ahead and have Excel calculate the correlation for you. So let's go back to our activity packet and record this information. So our regression equation is y equals 0.0543x minus 0.9764. And then our correlation value is r equals 0.952. And remember, the r value is what we're really after, so the r squared is an intermediate step to get there. Do the scatter plot and correlation support the idea that higher coffee prices increase the loss of forest? I'm going to say yes, because the scatter plot showed a positive linear trend. And the correlation value is close to 1. So this tells us that the correlation is a strong value. Okay, in Module 4, we'll look at just how strong we look at to make assumptions. And so you can skip ahead to the Module 4 vocabulary if you want to know how exactly high something has to be to classify as strong. For Module 3, we just want to say, oh yeah, it looks like it's pretty close to 1. Okay, go ahead and work on the group assignment for Module 3 and make sure to put your questions and comments in the Desire to Learn forum.